This is for Year 11 methods. It comes out of 14I. Question number 3. I'm drawing this particular function, that's sine 2x minus pi on 3, close bracket, over this particular domain. So I need to draw it from 0 to 2 pi. Part A asks me to find f of 0 and f of 2 pi, because that will find the endpoints. So f of 0 will equal sine of 2 times 0 minus pi on 3, which is the sine of minus 2 pi on 3. Where is minus 2 pi on 3? If I measure in the negative direction, that's minus 3 pi on 3. Therefore, minus 2 pi on 3 is here in the third quadrant. All stations to Calcutta, it's going to equal negative sine of pi on 3, because in the third quadrant only tan is positive, and that's going to equal negative root 3 on 2. Now, I know that this has a period of 2 pi divided by n, and n is 2. It's got a period of pi, which means if f of 0 is equal to minus root 3 on 2, f of pi is also equal to minus root 3 on 2, and f of 2 pi is equal to minus root 3 on 2, because after one complete cycle, the y value will be back to where it started at the start of that cycle. I could confirm it. F of 2 pi will equal the sine of 2 times 2 pi minus pi on 3, which is the sine of 2 times 5 pi on 3, which is the sine of 10 pi on 3. And that's going to be 3 pi on 3, 6 pi on 3, 9 pi on 3, 10 pi on 3 is here in the third quadrant, the same as this, so I'll get negative root 3 on 2. So I know my endpoints. They're both equal to negative root 3 on 2. Now I'm going to sketch the graph. Okay, I'd like to sketch the graph of y equals sine of 2x, and then I'm going to translate it to the right, pi on 3. Okay, so I know my amplitude is equal to 1, therefore my maximum will be 1, and my minimum will be 0, and my median will be 0. So median will be negative 1. So I'll put in, so I'm going to make that 2 pi, and I'll make that pi, and I'll put in a guiding line which will give me my 1 value, and a guiding line will give me my negative 1 value. I know this divides into quarters, so that's pi on 2, and that's pi on 4, and that's 3 pi on 4, and I'll divide this into quarters as well. So that's going to be 3 pi on 2, pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi on 4, 6 pi on 4 simplifies, 7 pi on 4, 8 pi on 4. Beautiful. And I will, in one cycle, I will start at 0 because it's a sine, and I'll finish at 0 and I'll be there, and then I'll go up to there and I'll come down to here. And this will be what the first cycle of sine of 2x looks like. And I will finish here and I'll be there and I'll be up there and I'll be down here. So that's what my second cycle, drawing it from 0 to 2 pi looks like. Okay, now I need to move pi on 3 to the right. I've got pi on 4s and pi on 3s, therefore I'd like to divide my grid into pi on 12. If I'm going to divide a pi on 4 into pi on 12, I need to divide it into thirds. I need 2 marks equal space, and they will be my 1/12, or my pi on 12s. Okay, now every point on my original curve gets moved pi on 3, which is 4 pi on 12, to the right. Okay, So this point goes 1, 2, 3, 4 to there. This point goes over to there. This point goes over 1, 2, 3, 4. This point goes over 1, 2, 3, 4. This point goes over 1, 2, 3, 4. This point goes over 1, 2, 3, so 1, 2, 3, 4. This point goes over 1, 2, 3, 4. And this point goes over 1, 2, 3, 4 and then goes off the scale. So this turning point is 1/12 to the right of 2 pi. This turning point is 1/12 to the right of pi. Therefore, a turning point will come back in at that point there. I know that I finish at 2 pi and minus root 3 on 2. And I know that I start at 0 minus root 3 on 2. Therefore, this is going to be my end curve. And my tablet doesn't do my drawing justice. Sorry, finished there. Okay, now how can I find my x-intercepts? They're all labelled there for me because they're on 12ths. 1, 2, 3, 4, pi on 12, which is pi on 3. 5, 6, 7, 8, 9, 10, which is 5 pi on 6. 11, 12, 13, 14, 15, 16. 16 pi on 12 is 4 pi on 3. 16, 17, 18, 19, 20, 21, 22, 11 pi on 6. And there's my endpoint there. So there's my graph of f of x equals sine 2 brackets x minus pi on 3 over the domain 0 to 2 pi.